Hi, seems like I'm live now. So, may I have a quick attendance kind of thing? I know it's not valid here, but still, I would like to know how many people are here in the stream itself. So, we would just wait for around 1 minute itself and then we would proceed right away. Okay, so let me see how many people are there. At least, if you're watching, just give me a quick one in the chat, at least. A hi would solve the purpose. Okay. Okay, so we have some people live now at the moment. Okay, so without any further ado, let's start then. Okay, so today we have a very interesting topic to cover. Okay, today we would be solving question, then we would be trying to bring down the algorithm. The focus today would be less on algorithm, and then we would try to see what are the requirements we need. Okay, and then we would see how to get the best data structure to use on that particular thing itself. Okay, so yeah, fair enough. So let me just present my screen and we can start right away. Okay. Yeah, just a sec. Okay. Fair enough. So just a sec. Okay. So let me just share my screen. Hi Paul Sammal, how are you? So yeah, fair enough. So let's discuss now. Okay. So the first question would be, we are given an array of n positive integers. It means that every element would be greater than 0. Okay, so we have three sets of numbers: negative, 0, and then we have the positive values. Okay, and then we need to find the k largest elements from the array itself. Okay, so it's a simple question. बहुत सारे एलिमेंट्स दिए हुए रहेंगे, उन्हें उनके बस लार्जेस्ट के वैल्यूज हमें देने हैं. The output would be printed in decreasing order. Okay, so what we can do is we can see that 12, 5, 7, 8, 7, 1 and 23. 787 is the largest value, and then 23 is the second largest value, and we need to return two values according to the decreasing order. Now, let us try to think. Okay, the first way to solve this would be simply to sort the array and then reverse the array itself and then find the k largest. But instead we can skip that reverse part also. Okay, so what we can do is we can simply have something like 1, 5, 12, 23, and 7, 8, 7 itself. Then what we can do is we can start iterating from the back, and then we can take up this number, insert it to a vector, then we can take up this number, we can insert it to a vector. We would keep inserting numbers till we have k elements itself. Okay, so what would be the time complexity of this approach? The time complexity, okay, just let me just arrange this to a very, yeah, now it seems correct. Okay. Okay, so now the approach is very simple, but what we are basically doing here, we are doing in place sorting that would do as n log n. Okay, we can use quicksort or something, and then fast forward, we are again iterating, would make it big O of n log n. So can we do better than this or not? Okay, we know that the value of k is less than the value of n itself. So let us try to optimize our approach. Okay, the second optimization of our approach can be that we take hold of first k elements in the array, first k elements in the array itself. Okay, so हम what can we do is हम लोग पहले k elements ले सकते हैं. Then what we can do is we can take hold. Okay, suppose there are k elements. Okay, let me just try to do the dry run itself. Okay, so we have 12, 5, 7, 8, 7. So we have 12, 5, 7, 8, 7, and then we have 1 and 23 itself. Now what we can do is, I told that the focus would be less on algorithm and more would be on data structure today. Now what we can do is, first we can insert these two elements. Why? Because we are told that the k is 2 here. So what we can do is we can insert 12 and 5. Then we come across 7, 8, 7. Then we see that if this 787 is greater than the minimum element of these part or not. Yes, 787 is definitely greater. So we would bring out this 5 and we would assign 787. Okay, then we come across 1. The minimum element of this is 12 and 1 is less than 12. So our values in this circle won't be updated. Then we come across 23. So the minimum value here is 12 and 23 is greater than 12. So what we would do is we would update 12 to 23 and we would have 787 itself. Okay, so क्या किया हम लोग ने, पहले k एलिमेंट्स लिए और हर एक स्टेप में सबसे छोटा एलिमेंट से कंपेयर कर रहे हैं. अगर सबसे छोटा एलिमेंट को हम लोग अपडेट कर पा रहे हैं, ओके, then we are replacing that element. Okay, we are replacing that element and then we are moving forward. At the end, whatever we are getting in a nutshell, that is our answer itself. Hope I am clear till this point. Okay, so now why is this working? Okay, why is this working? So why is this working? So this is working because we are comparing the minimum element. Okay, why minimum, not the maximum? We have two options, to either compare the minimum, to either compare the maximum. So we want the k largest value. So if we want to find the k largest value, then the minimum should also be a very strong candidate for being the maximum. Okay, hope I am clear till this point. Okay, then what we do is we take hold of the minimum and then we update the minimum itself. Okay, so can I have a quick yes or no that I am clear till this point or not? Okay, quick yes or no that I am clear till this point or not. I would wait for just 1 minute itself and then I would proceed. Okay, how are we doing itself? Just tell me if I'm clear till this point or not. Hi, Paul. Thanks a lot, Richie. Thanks a lot, Payal. Can I have 1 or 2 more replies and I can proceed forward? Okay. Okay. 4 people are following up. Thanks a lot. So let me just go to the clear it, sir, please. What clear it? Sumit, can you tell me what do you mean by this? Okay, fair enough. So we have a bag kind of thing. We have a big bag and we have many elements here. So again telling you, suppose this is the smallest element, then we need to update that also. So if we start updating the minimum element, then we can see that the maximum element, if we have a greater element than that, it would automatically be updated. Okay, I would repeat, don't need to say please, that's absolutely fine. You don't need to say please, I would just do the iteration again. Okay, so see, I'm telling you, what is happening. Okay, क्या कर रहे हैं, just इस तरह से सोचो. Okay, सपोज आपके मम्मी ने बताया कि बहुत सारे साइजेस के आलू लेने हैं. We take that in a bag. Okay, and we take the minimum potato. Okay, and we start updating that. So suppose there is a large bag kind of thing. Okay, large bag kind of thing, and we have a minimum potato and we have a mini. Suppose this is size 1, this is size 2. Then we have a size of 1.5, then we have a size of 2.5. Okay, so what we do is we take this 1.5, we remove this and we assign it here 1.5. Then we come across 2.5. We can see that the minimum value is less, so we are updating this value only. Okay, so if the next value is 3.5, you can see that even the maximum is now being the minimum. Okay, so यहाँ पे change of role हो रहा है. Okay, now let me tell you this. Okay, suppose with respect to that we have 5 and we have 12. So the minimum value of this is 5 itself. Then we come across 787. So if we come across 787 and it is less than, it is greater than 5, so we replace 5 with 787, and now the minimum element is equals to 12. Okay, then we come across 1, the minimum element, it is less than the minimum element, we won't update it. Then we come across 23. So now 23 is greater than the minimum element. So see, earlier this was the maximum element, but now even the maximum element is getting updated to 23 itself. Okay, that is one. So now am I clear, Sumit and Onkar? Am I clear or not? Can you please give me a one in the chat and I would quickly proceed. Okay, so what are the requirements? Okay, what are the basically the requirements of this approach? So what we want is, okay, we would talk about the cost and all after this. Okay, requirement. Okay, okay, Omkar or Sumit मुझे chocolate देंगे. Okay, you both would give me a treat. Okay, now what are the requirement in this? Okay, so first we are inserting elements. Okay, so data structure would hold elements. Next, we need the minimum at each step. Okay, so what we want the minimum at each step. Okay, so we want the minimum at each step. So if we want the minimum at each step, we need to update it also. Updating means that we need to remove the minimum and insert a new element. Okay, so insert option should be there, and then removal of minimum element, removal of minimum element itself. Okay, and we want all this thing to be very cost effective. Okay, so whenever we think about minimum at each step, or we want sorting at each step, we should think about only one data structure. Can you tell me what would be the data structure that can be used at this point? Just tell me, looking at all the requirements, tell me the data structure that you might need. So we can insert elements, we can remove elements, and we can get the minimum at each step. So, batao kaun sa, what data structure can be used at this point? See, we should have the basic functionalities with the cost and all. So we should know that map has an insertion cost of log n, map has a deletion cost of log n, map has a find function of log n. Okay, these all things should be known. Then we should also know about set also. We should also know about array also. Okay, these all things should be known. Suppose we want unique elements. Okay, I'm just telling you the gist. You can quickly see the recording at this point. So suppose we want all the unique elements in sorted order, then we should use set. If we want all the elements but not unique, there might be repetition, then we should think about what? We should think about multiset. Okay, fair enough. Yes, Ayush Agarwal, you are absolutely correct. Okay, so we would be using priority queue. Okay, I would just write PQ, or let us write priority queue. Okay, priority queue, or basically we can write it as the min heap thing. Okay, those who don't know what is priority queue can say that it has all the functionalities that it is listed here, with everything, the cost with a log and approach. Okay, now before using that element, before using the data structure, just see if we are able to improve or not. Because if using a new data structure we are not able to improve, there is no point in doing that. Okay, so what we can do is we can just go back. Okay, we can just go back, and then we can read this part only, and then let us see. So the number of elements, is n itself. Okay, so at most we would insert all the elements, so it would be k operation, then again the remaining operation also. So we can have n plus k log k itself. Okay, all the elements have their respective priorities in priority queue. Okay, we would be talking about. So in priority queue, okay, this priority thing, this priority thing, okay, what do you mean by priority of an element? So you can declare the priority of an element. How? You can declare the priority of an element according to the smaller element, small or large, okay, or big or small. What do I mean by this? That if we assign a min heap, okay, if we assign a min heap or the default priority queue in C++stl, then the maximum element, so sorry, this is not the default one. Okay, so this is the min heap thing, and this is the default one. Okay, so now if we have a min heap priority queue, then the smallest element would be at the top. If we have a max heap priority queue, then the maximum element would be at the top. Okay, and the order would be maintained. Am I clear, Sumit? Okay, now let us see the working of priority queue. So we have this simple part. Okay, fair enough. Now what we can do is we can have a priority queue itself, okay, of int, and we would name it as PQ. Then what we would do is PQ dot push the element 1, okay, and then I would just copy paste this, okay. By the way, to select the whole line, it is Command L or Control L in Windows itself. Okay. So suppose we insert 4, then we insert again 0, then we insert again 10. So now if we print the top element of the priority queue, PQ dot the top element, then what would be the value itself? The value is 10. That is, the maximum element is at the top itself. Okay, so now we know that if we have a min heap, so if we have a max heap, then the maximum element would be at the top. Okay, so now if we want to construct a min heap in C++stl, then the syntax is a bit different, and it's too long, not too long, it's a little bit long, and it's difficult to memorize. Okay, so is there any shortcut or not? And there is a shortcut, but that is basically a trick. Okay, that is basically a trick. So how many of you have difficulty in initialization of min heap in C++stl? Okay, so we can say that our problem is now min heap in C++stl. So if you look at the stl to implement min heap, it is a little bit difficult. Okay, so how many of you have this problem that you are not able to memorize this? If there are more than one people, I would be more than happy to explain you a trick so that we would convert a max heap into min heap by adding just a single integer. So quickly give me a one if you want to know me, if you want to know it. So let us see. Okay, so we have 10, we have 1, we have 2, and we have 5. Okay, now if we insert this in the priority queue, suppose we insert 10, then 10 would be inserted at the top, then 5, then 2, and then 1. This would be inserted like that. Now what I say is when we insert in the before inserting, so just before insert, okay, multiply it with -1, and after taking out after taking out again multiply it with -1. This is what you need to do, just this, nothing more, nothing less. This is the only thing that you need to do. Okay, now let's talk about this thing, why this is working. So suppose before inserting into the priority queue I have -10, then I insert -1. So -1 is greater than -10, so it would be at the top. Now if we insert -2, then this 10 -10 would go down and -2 would get inserted at this position. Then we have -5. Then we access the top element, and just after taking it out, we multiply it -1 with again -1, that is equal to 1. Now suppose we pop this element, then we again have -2 multiplied with -1, then we have 2. So we can see that by using the default one in C++STL, we are able to implement min heap. And this is a very popular trick that is used in competitive programming. Okay, so I hope this would need an applause, but I don't need an applause. Just send me a quick 2 in the chat, or a thank you would solve the purpose. Okay, and then we would proceed. Okay, but am I clear with this idea or not? Just before inserting, multiplied with -1. After taking out, multiplied with -1. Okay, because I see that programming shouldn't be just mugged up and understood. Okay, because if I know that vector, the bracket and int and the name I want, I would use the same thing, priority queue, bracket the data type I want and the name itself. Okay, so this is a very good thing. I observe thing. Okay, you are most welcome, Ronak. Thanks a lot, Arijit. Thanks a lot, Rishi. Thanks a lot, Sharonil. Okay, so in this problem, what we need to do is we need the minimum at each step. So we want the min heap. So we now have the min heap. So what we would do is we would have the same type. Okay, we would have the same type and we would start the implementation live itself. Okay, so let us do the implementation. Okay, so now instead of ARR, I would make it A itself. Okay, then what I would do is I would have the prior. By the way, just after this stream, just towards this end of the stream, I would also tell you one more alternative of a data structure. Just wait for it, and that would be absolutely fantastic. Trust me. Okay, priority queue itself, and then we have the int. I like to name it as pq itself. Okay, then what we do is we have a for loop int I is equals to 0, I is less than k, and I plus plus because it is 0 index, and then pq dot push the I itself. Okay, a of I. So priority queue of int data structure because we have int, and then we insert all those elements. Okay, then what we do is we have the we start comparing that. Okay, but we are making a mistake. If you observe, I is less than n and then for the rest of the elements we would iterate. But before inserting, I told that I would just multiply it with -1, and that max heap would be changed it to min heap. Okay, this is how it would be changed. That this one integer would change all the game we have. Okay, then what we would do is we would take hold of the top element. Top element would be -1 multiplied with pq dot top itself. We would take hold of the top element. Okay, and then we are multiplying with -1, then we would have the minimum element, the original minimum element, because -1 into -1 is 1, and multiplying 1 with any number won't disrupt the value of that number. That is the reason we have -1 itself. Then if the value tp is less than the current value, what we would do is pq dot pop itself, then we would again push this element -1 multiplied with the number itself. Okay, and then we would proceed. Okay, I hope that after this we would have this, because if we are inserting elements, we make sure we are popping up the elements, so the number of elements k is kind of preserved. Okay, so if that element is there, we would just push and we would pop that element. Next, what we would do is, now we have the minimum element, but we want that in decreasing order. So we would have the vector of int to save the answer. And while the priority queue is not empty, what we would do is answer dot push back. Okay, pq dot top multiplied with -1. Okay, then what we would do is pq dot pop, so that we have the next element. Then after that, we have all the elements in sorted order, but we want the reverse of it. So I would just show you and then I would just reverse it. Okay, so I would return the answer itself, and then let us just compile and run, and we would see that. Okay, so we want 787, but the output here is 23 and 787, just the opposite of this. So what we can do before returning is answer reverse answer dot begin comma answer dot end itself. Okay, now let us see that. Okay, we have the particular value. Yeah, the Java -1 trick in Java in priority queue would solve the purpose. Don't worry about that. Okay, so we have successfully solved. So what I want is, I want to know if you are able to gain something from this or not. Okay, and then we would move to the next problem, which is a very famous problem, and then we would just end the stream. Okay, and this time I would tell you a very good trick of this. This trick would work in all max heap to convert it into min heap. If you have min heap as the default one, you can convert it to max heap by using this. Okay, so it can be toggled. Min heap can be converted to max heap, and max heap can be converted to min heap by using this trick. Okay, so now in this question, what we need to do is we need to find, so FPL, show previous slide. This previous slide, yeah, sure. Quickly take a screenshot. Okay, 1, 2, and 3. I hope you have taken the screenshot. You don't need to say please. Please don't say me please. I'm not accustomed to saying please. You are a human. I am a human. I respect you. You respect me. If we use max heap, 787 would be on the top right. Yeah, absolutely. देखो max heap में max thing है, so maximum element पहले है, the max heap में max thing पहले है, इसका मतलब maximum element पहले होगा. This is how I remember, and this is how I map these all things in my mind. No sir, code part of the presentation. Yeah, sure. See the code part. Okay, 1, 2, 3. Okay, I hope you have taken the screenshot. Okay. Now, the next part is we would find the next greater element on left side. Okay. Next greater element of the left side. Most welcome. Okay. So, what we do is suppose the next greater element of 1 is 3. So, it is 3 itself. For 3, it is 4. So, it is 4. For 2, it is 4. And for 4, there is no next greater element on the left right hand side. So, sorry, this would be right hand side. For you, it would be right hand side. For me, it is left hand side. So, for this side, it would be minus 1. So this class is useful for technical text. Yeah, this class is very useful. Sir, in previous question, can't we use Max Heap and pop k times? So if you use Max Heap and pop k times, no. You can't pop k times. See, if you insert all those elements and then you pop n minus, so n minus k would be the elements that is not needed. So if you pop all the elements that is not needed, okay, that's absolutely fine. But inserting all those elements in the priority queue would take log n. So कितने elements है? There are n elements, and inserting them would cost a log n operation. So basically, you are again taking hold of n log n approach. Okay, that is why that is not an improvement. But basically, what you can do is you can simply sort if you want to use this idea. But if you are using this idea, you can see that the value, the number of elements in the priority queue never exceeds k. Okay, that is why the cost of those collectively is k log k. Okay, am I clear, Richie, or not? Just tell me that. Yeah, this class is very useful for so just try to see, we have a core subjects to cover for technical test. Okay, then we have other things also. So try to minimize the amount of mugging up in the DSA part. Okay, yeah, that's absolutely fine. Okay, so in this problem, what you need to do is you need to start looking on the right hand side. And suppose it is 1, then 0, then minus 1, then 2. So what we do is we start from 1, and this is not greater than 1, this is not greater than 1, this is greater than 1. So the next element we find when we start going towards the right hand side, the first element we get that is greater than the current element, we say that for this element, this is the next greater element. Quickly send me a 1 in the chat if you have understood this question. Okay. Okay, fair enough. This is what you need to do. So let's do the dry run of 1, 3, 2, 4. So we have 1, 3, 2, and 4. So for 1, we come across this. Yes, 3 is greater than 1. So what we say is, we say for 1, the next greater element is 3. Then we come across 3, 3, 3, 3, 2 is greater, 2 is less than 3, so this is not the case. Then 4 is greater than 3, so we can say that for 3, the next greater element is 4. Then from 2, we start traversing, and we find the first element 4 that is greater than 2. So for 2, the next greater element is 4 itself. Then we come across 4, we start moving on this side. There is no elements to compare. If there is no elements to compare, it is mentioned in the question that we need to report minus 1. That is how the answer to this is 3, 4, 4, and minus 1. Thanks a lot, Payal. Thanks a lot, Darshan. Thanks a lot, Ronak. Okay, only this much people is following up. Am I so boring? Okay. So now, the first brute force approach, okay, the brute force approach to this is that for each element, we try to find the next greater element. Next greater element. How do we do that? I would just simply show you. Okay. So what can be done is we can have a for loop int I is equals to 0, I is less than n, and I plus plus. Okay. So this should be I is less than n. Okay. And then we would have a counter for j itself. for int j is equals to int j is equals to I plus 1, j is less than n, and I plus plus. Then if a of j is greater than a of I, we would just say that the next greater element nge of particular I is equal to a of j. And if we are not able to find, we would initialize everything. We would initialize every value of nge with minus 1. So even after iterating the whole value, if the value of nge of I is equal to minus 1, then we would say that yes, it would remain minus 1. Okay? That is how we can do it. Okay. Sridhar Pujuri, tell me the point where you are not able to understand. Okay. So now this is the brute force approach. So for each element, so for suppose I am standing at the index 0. So I need to iterate over the whole array. So for one element, I am doing n operation. So 1 into n and n into n, multiplying n on both sides. Then we have for n element, we would do n square operation. So the time complexity of this approach is big O of n square. Okay. Can we improve over this? Yes, we can definitely improve over this. How can we? Okay. Let's take the same array. I have 1 3 2 4. Okay. What I say is we would find a data structure. Okay, we would just name it as ds as of now. We don't know which data structure we are using, just we would use a data structure. And then what are the things we do? If ds is empty, if ds is empty, then we would insert the current element. So we would insert the current element. If the ds is not empty, okay, and if not, what we would do is we would keep keep popping out elements less than current. And for all these elements, this is the next rotor element. And then we would insert the current. If this is not the case, okay, if this is not the case, we would just insert the current. Am I clear till this point or not? Okay, how this is working, I would show you. Okay, don't worry about this. So we have 1 3 2 4. This is what we had. So we have this 1 3 2 and 4. So initially the data structure is empty, so we would insert 1. Then we have 3 now. So 3 is less than the last element, So we would take out this 1 and we would say for 1, the next greater element is 3. Now the particular data structure is empty, so we would insert 3. Next we come across 2. 2 is less than the last inserted element. So we would insert that. Next we have 4. So for 4 is greater than the last inserted element. So we would remove this 2 and we would say for 2 the next greater element is 4. Then we have 3. So for 3 is also less than 4. So we would remove this 3 and we would say for 3 also the next greater element is 4. Then we have 4 itself that would remain. So all the elements that remain, they have no next greater element. So now am I clear with this or not? Why this is working? What is the algorithm? Then we would see how to decide upon the data structure again. And trust me, if you reply quickly, I would just need 5 more minutes. Just 5 more minutes and I would leave you. Don't worry, I won't bother you. Trust me. I won't disturb you that much. Quickly reply with a 1 in the chat. Quickly, quickly. Okay, so we have more people telling me 1 itself. So now let's get back to what we have decided. Okay, so let's get back. So to do this, what are the things we need? Okay, what are the things we need? Let's discuss that also. So we would need, okay, we would need a data structure with these all requirements. So I would just write requirements. These are the requirements. What are the requirements? The first requirement is we need to insert elements. So we need a data structure where we can insert elements. So if you don't mind, can you explain it again? Why would I mind? This is my kind. You're not bothering? Yeah. Okay. That's that. Thank you for. Okay. So I would just show you again. Okay. I would tell you, read you this. So हम लोग क्या करेंगे ना, एक डेटा स्ट्रक्चर लेंगे. अगर डेटा स्ट्रक्चर पूरा खाली है तो उसमें जो करंट एलिमेंट है उसको अंदर डाल दो. ओके. अगर डेटा स्ट्रक्चर खाली नहीं है तो क्या करेंगे, उस डेटा स्ट्रक्चर में जो लास्ट इंसर्टेड एलिमेंट होगा उससे कंपेयर करेंगे. अगर लास्ट इंसर्टेड एलिमेंट करंट एलिमेंट से छोटा है, सो वी वुड से दैट वो लास्ट इंसर्टेड एलिमेंट का नेक्स्ट ग्रेटर एलिमेंट वो करंट एलिमेंट है. ओके, दिस इज व्हाट वी वुड डू. Okay, sorry. So this is what we would do. Last inserted element का current element. So we would keep popping. जब सारे elements खत्म हो जाएंगे तब वो last current element को भी अंदर डाल देना. Okay. Now what we would do is we would start the iteration 1 3 2 4 1 3 2 4. So let's do. So first the data structure is empty, we would insert this. Then we have 3. 3 is greater than the last inserted element on the data structure, so we would say that for 1 the next greater element is 3 and we would remove that. Next we have 3, the data structure is empty, so we would insert that. Next we have 2, that is less than the last inserted element, so we would simply insert it. Then we have 4. 4 is greater than the last inserted element, so we would say that for 2 the next greater element is 4 and we would remove this. Still we have the next greater element greater than the last current element. So last element for 3, the next greater element is 4. Now we would insert 4. So for all the elements that remain, we can say that they don't have an next greater element. So am I clear, Sridhar? Okay, fair enough. So let's move forward. Okay, so what can you tell us what basic approach you're following to select data structure for a question? So see, we have data structures and algorithm. The whole engineering career of CS and IT is dependent on this. Okay, so we can safely say that first we need to design the algorithms. Then according to the algorithms, we need to write out the requirements. This is what I'm doing. I'm trying to list out the requirements. And then I should initially beforehand know that which data structure is efficient in doing which operation. मुझे पता होना चाहिए कि मेरा कौन से दोस्त को फुटबॉल खेलना आता है. My which friend is able to play good football. My which friend is able to do good programming. My which friend is able to entice girls. Okay, these all things. Okay, this is the proper way of doing that. Arijit, am I clear to you or not? So the first requirement is that we should be able to insert elements. The next is we should insert elements to the back. So insert at back. Insert at back. The next thing is we should access the last inserted element. So access to last inserted element. Inserted element itself. The next is the third point is, what is the third point? The third point is we can remove last inserted elements. Remove last inserted element. This is what we need. Okay, so now first we can insert elements from the back, access to the last inserted element and remove the last inserted element. Last time also I never told you the data structure that I need to use. This time also, Arijit, especially from you and others, tell me which data structure is very efficient in doing all these operations. Insert at the back, access to the last inserted element, and also removal of the last inserted element. Tell me which data structure should we select? Tell me. Quickly tell me, and then we would quickly move forward. Bata, quickly tell me, quickly. Stack, Ayush Agarwal. No, I want the reply from someone else because Ayush Agarwal, he was the last time also he was the person. Ronak, thanks a lot. Okay, thanks a lot. Okay, Arijit Kumar Pandab, now you know how I'm doing this. Thanks a lot. Okay, so we should be using stack itself. Stack follows a thing known as last in, first out. So whenever you are told in the interview that which data structure follows last in, first out, the first thing that should pop in our mind is stack itself. Okay, 1324. So let us code this in the sublime text. Okay, so we have the simple thing, we have the stack of int and we would name it as st, and then I would give you a wonderful, trust me, I would give you a very wonderful idea, okay, of data structure this time. Trust me, I won't wait you. Okay, so int a dash is equal to 1 3 1 and 3 and 2 and 4 itself. Okay, and we have the size equals to 4. Okay, then what we do is we start the iteration. So for this we would have I is equals to 0, I is less than n, and then I plus plus. Okay, so now what we do is we would first check if the stack is empty. So if the stack is empty, we would push that in the element itself, a of I. If the stack is not empty, there might be two conditions. So while the stack is not empty, while the stack is not empty, and the last element st dot top element is less than a of I, the current element. So we would say cout st dot top elements next greater element is the current element itself. After I am done with this, and then we would pop this also, st dot pop, and then we would insert this st dot push the current element, and then we can safely say that while the stack is not empty, the remaining elements, for all the remaining elements, we can say that this is happening. st dot tops next greater element is minus. Now let me just quickly check. So we have 1324, we have size as 4. Then if the stack is empty, we are pushing the current element. If the stack is not empty, we are checking if the stack is not empty, and we are taking hold of the top element. Okay, if it is less than the current element, we would simply pop and say that for this element, the next greater element is this, and we are popping that. So let us print that. Okay, so let us do an end line too, because that is just disrupting the answer. Just a quick idea, if you are into competitive programming, remember to use this instead of end line. Okay, even if you are giving machine test. Okay, so for 1, the next data element is 3. So for 2, the next data element is 4. And for 3, the next data element is 4. And for 4, the next data element is minus 1. Okay, fair enough? Okay, I should be clear with this. Now, a pro tip to this. Okay, a pro tip is use, so in stack, there is some problem with stack. If we are using element, if we are using stack, then we can only access last element. We can only access the last inserted element, but not other than that. There is no indexing kind of thing. So if I tell you that we have an improved stack in the STL itself, what I say is instead of stack, start using something known as vector. Why vector? Because accessing the last element of the vector and popping the last element of the vector, both are big O of 1. Okay, so basically, let us now try to think about. So let us see the time complexity of this approach too. Okay, so now let us do the next criteria. So now let us see. So for this, we are initializing, and all will take big of constant time. We are pushing an element in the stack is taking big of 1, and this every element is getting transferred out once. So basically, all together, we are doing big O of n. That is why the time complexity is big of n. Tell me if you have any problem in the time complexity. I would explain you why this is big of 1 n. So what I say is use vector over stack. So now let us solve this problem using vector itself. Okay. So what we can do is we can have a vector. Okay, and there is no top kind of thing. While vector is, if the vector is empty, we would insert element, and this should be pushed back. Okay, this would be pushed back, and instead of top I would have something known as back. Okay, then this one would also be back. And if you want to remove all the occurrences at once, then use command D or ctrl D. Okay, and this would be pop back thing. Okay, then this would also be what, back, and this would also be pop back. Okay, so let me just see if I made any mistake or not. Yes, I made a mistake. So while the stack is empty, we would push back. If the stack is not empty, we would see the back element, and then we would pop back the element. Yes, this is fine. Okay, so this should be okay. We are pushing somewhere. Yeah, so we have pushed back. See, this is again working the same. So if you are giving test online, or if you are working on an online judge, you can use vector where you can even access the indices too. So though trick, so let's sum up all the things. So summing up all the things that we have done till now is the first one where we know a question, the largest k element. It is a very famous question. It has appeared in which companies? Let me tell you. The company tags are Amazon, Google, Microsoft, Samsung, and Walmart. The next question we discussed was the question of Flipkart, Amazon, Microsoft, Adobe, and Name My Trip. I took the most famous two questions. The next thing which we did was we took up the courage to have the requirements and then decide a data structure, and no data structure was revealed by me in the whole stream. It was revealed by one of you, between you yourself. Your brother or your sister revealed you which data structure should be used. The next thing is that we implemented it live. Then we learned two tricks. What are the two tricks? That using min heap, we can convert it to max heap, and from max heap we can convert it to min heap without changing the initialization. Just by multiplying with -1 before inserting and multiplying with -1 after taking out. This is the thing. The third thing was using vector instead of stack. So can I have a quick thank you, and then I would just leave. So now it's an open forum. I have 5 minutes to spare. You can ask me anything related to your placements or something. Okay, so now we have the ask me anything session. Sorry, ask me anything. Okay, so now you can ask me anything you want. Okay, does vector take one for popping in Java as well? But as far as I know, there is no vector. There is array list. Okay, and it has been a long time that I have been into Java. So I'm not that much specific that which data structure is using what. The next thing was, thank you, thanks a lot. You're most welcome, Richie. You're most welcome, Shamal. Okay, by the way, this is my LinkedIn username. So I am receiving no placement questions as of now. So I think that I don't need to wait very long. I think no question because no one is that. Why would be anyone? Okay. So this is my LinkedIn username. You can send me a connection request if you want. Okay. So I see no more doubts coming in. Still, we would wait for the next 30 minutes and then we would leave itself. Okay. Okay, so that's it for today. Thank you and have a nice day. Take proper rest, but remember to be consistent because this programming thing is all about consistency. It's not about doing 10 questions in one day, but it's about doing one question each day or two more than two questions. I'm a non career student. What should be my preparation plan for placements? Okay, non-career students, what do you mean by non-career students? So the preparation plan remains the same. You can start off with the basics, then you can move to start solving school level question, then easy level question, medium level question. Now there is one more thing. You don't need to learn all the data structures beforehand. Rather, what you can do is you can take up a question. Now there are two probabilities. Either you already know that thing that needs solving that question, but you are not able to use that. That means you need the proper practice on that particular topic. The next is that you didn't knew this topic. If you didn't knew this topic, that means that you need to learn that topic, do some practice, then again come back to this question itself. When I'm good to learn DP, you are good to learn DP when you are good with recursion, very good with recursion. I don't like coding. I'm interested in networks. Where do I want to start? If you are into networks, what you can do is you can talk to some people who are very good in the industry of networks, because I can say that I am little bit good enough in coding, but in industry, so you should talk about from the best. If you should take flavor from the best. Okay, so I'm in my fifth semester. Yeah, I'm also in my sixth semester. Okay, non-career means I have don't have 60% in 12. That's absolutely fine. I don't think many companies have removed that criteria thing of 60%. What are data structure? Must know list for solving many questions, at least approaching them. So you need to know set, you need to know multi-set, you need to know priority queue, you need to know array, you need to know queue, you need to know stack and all. You need to learn linked list. So can data structures alone give placement and job? No. Data structures and placement are a pair of shoes. Okay. If you are using one pair, one shoe, not a pair of it, it is useless. So without algorithm, data structure is useless, and without data structures, algorithm is useless. Okay. But with both, they are a very good thing. Okay. Okay, I see no more doubts coming in. Okay, we still have a minute left. Okay. We have a lot of people. We have 50 people to be honest. Okay, so that's great. Okay, so how to prepare for placement? This is already answered. Okay, so that's it for today. Thank you and have a nice day. It was very nice interacting with you, and the interaction from your side was very good to be honest. Okay, but just be consistent in this game. Thank you.